Hello, geometry. We have a do now at the top here. Determine whether each pair of triangles has enough information to be congruent by side, 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 angle, side, or hypotenuse, leg. Explain how you know. So if you want to make one of our congruent parts tables and reasons, that sounds great. For this one, now that you've had a chance to practice, for this one, you get that it is side, angle, side. You've got corresponding angles here with your parallel lines. So those correspond, therefore they're congruent, side, angle, side. For this one, you actually know a leg, and then FH is the hypotenuse. So this is by hypotenuse leg. And then for this one, JL is congruent to itself by reflexive property or identity statement, either way. And therefore, you know side, side, side. So all three of them are congruent. So today we're going to learn our last two ways of determining congruence. Our first way right here is angle, side, angle. So if two angles and the included side, right? With side, angle, side, the angle had to be included now. With angle, side, angle, the side has to be included. So if two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the triangles are congruent. All right, so that means, or included, I should say, means that the side is between the angles. All right, so if I list this out in order going from, I like to go from left to right. So I'm going to start with angle A is congruent to angle D. They both have one whooshie. Then we would have side AB is congruent to side DE. And then we would have angle B is congruent to angle E, right? Side, angle, side. Then we would have that triangle ABC is congruent to triangle DEF. All right, so that's angle, side, angle. And then the last one, angle, angle, side. So if two angles and a not included adjacent, that's what I meant. Adjacent side of one triangle are congruent. And two angles, they use non-included. Fine, non-included. Side of another triangle are congruent, then the triangles are congruent. So non-included means a side not between the angles, right? It's a side not between the angles. So again, I'm going to start on our far left here and work my way kind of clockwise around. So angle A is congruent to angle D. Angle B is congruent to angle E. And then BC is congruent to EF. All right, so it goes angle, angle, side. Whereas this one up here was angle, side, angle. So those are different. In this case, let's actually do CBA for our triangle, CBA. And when we match that up, we get that it's congruent to triangle FED. All right. So two new ways, angle, side, angle, 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 side. I will tell you now, I never, ever, ever, ever want to see side, side, angle. Okay, that doesn't exist. It's non-existent. It's not true. We're going to talk about why during our meet. And I never want to see angle, side, side. That spells a bad word, okay? I don't want to. I have toddlers, so like, la, 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 la. I don't need to hear that. All right, so for our first proving, so to speak, using angle, side, angle, and angle, angle, side, we have here that SQ bisects angle RQT. Well, what does that mean, bisect? Bisect two sections. What's important? They're congruent. If it's an angle, that means that we have an angle here and an angle here. So let's write that down. So we know angle SQR is congruent to angle SQT. How do I know that? Definition of angle bisector. It also says that SQ bisects angle RST. So that means that this angle is bisected as well. So that means we know that angle RSQ is congruent to angle TSQ. How do I know that? Definition of an angle bisector. Remember, we only ever use 4 of these, so I have an extra box here. Don't worry too much about it. So we still need one more piece, right? We've got an angle, there's something we're missing. What are we missing? That does statement. QS is congruent to QS. How do I know that? Reflexive property. Or identity statement, whichever you prefer. I like reflexive property, as you can tell. So now, mark it if you know it. So now we've got triangle QRS is congruent to triangle QTS. How do I know? Now this is where it can get a little confusing sometimes. You need to look at the diagram, not your statements. Your statements are written in angle side order. But if we look at the diagram, I'm just going to focus on the top half, right? So the top half, I would have angle, side, angle. So this is actually angle, side, angle congruence. And again, I like to work my way from left to right. So this one we knew was angle, side, angle congruence. All right, down here we have JK, which is this guy, is parallel to LM, so like that. And then we have JL is parallel to KM, so like that. I know there's a lot going on. I'm not going to separate these triangles out because they don't overlap. And having parallel lines is really, really important because that means we know angles, which is super useful. Now, let's just start with a does statement on here because it's kind of nice to get the easy one over with, right? And that would be that KL is congruent to itself. So KL is congruent to KL. How do I know? Reflexive property. So now we can start looking at this, and let's just start with the JK and KL. So this guy and this guy. All right, I'm going to redraw that. Here's my JK, here's my KL, and then we can see that we've got a transversal right here. And it's like this. If we have a transversal, we know some angles. What angles do we know? We know this angle and this angle, right? So that would be this one right here and this one. So if I name them, that would be angle JKL, and it's going to be congruent to angle MLK. How do I know that? What kind of relationship do those angles have? I think it's easiest to look at this diagram and to see. How would we name that angle relationship? They are alternate interior angles. I told you it was never going away. Isn't it so exciting? It's like we spent months doing it for a reason. I feel good about that. All right, our next one is JL is parallel to KM. So it's this guy and this guy. And again, we've got a transversal right here, right? It kind of makes that Z. So our first shape was kind of a backwards N, and now we've got like a Z here. And we need to figure out what angles we know. So we know this angle and this angle. Why do we know those angles? Because they're alternate interior angles. Yay! All over again. It's so great, isn't it? All right. So if I translate from my little depiction here to over here, that would be this angle and this angle. So those angles are JLK, and it's congruent to MKL, angle MKL. All right, so now that we know that, we can see, if I just cover up one half, we can see that we have an angle side angle congruence. Angle side angle. And we've got one extra statement we don't need. All right, I'm going to let you guys try this one on your own. Again, it's got one more statement than you need. But we've been given that angle BAC is congruent to angle DEC. So let's mark it if you know it. And then we know that C is the midpoint of AE. C is the midpoint of AE. What do we care? Mark it. And I want you to remember, if you see this kind of X here, then you know something about vertical angles. So think about which angles you know. And you've been given the congruency statement. You just need to write your reason. All right, let's try some more over here. We know that triangle ABC is congruent to triangle angle ABC is congruent to angle CED. So ABC and CED, those angles. We also know that AB is parallel to CE, and we know that C is the midpoint. All right, so now we need to go through and write some statements down. First and foremost, angle ABC is congruent to angle CED. How do I know that? It was given. All right, it was given. And then we also have the C as the midpoint of AD. So AC is congruent to CD. How do I know that? Definition of a midpoint. Right, definition of a midpoint. And then we've got that we have some parallel lines here. I always think it's easier to redraw my parallel lines and then to see what the transversal is. So what touches both of them? Now, technically BC touches them, but that doesn't help us at all because it doesn't extend, so it's kind of, meh. There is another line that touches both of them, and that is this line right here, this AD. And that's useful because we know those angles are corresponding. So we have corresponding angles of parallel lines. And what are those angles? Well, that angle is BAC and angle ECD. If you know it, make sure you mark it. So now we actually have, and it doesn't matter which order you go in, although you want to go to the closest one, okay? So with this one, I actually think it's easiest to start at the top and to work my way around. You could start down here and work your way up as well. So it does not matter which way you do it. But I'm going to start up here, and I'm going to go angle, angle, side. So I'm going counterclockwise. You could do side, angle, angle. Then you look at me and go, but there is no such thing as side, angle, angle. Well, it can be reversed. So you can do it in either direction, all right? So if you come across a side, angle, angle, just reverse it and do angle, angle, side. All right, this is another one that I want you guys to try on your. So it says that PR bisects angle QSR. So QRS, dyslexia. And then we have on here that angle PSR is congruent to angle PQR. So if you know it, mark it. There is a DUS statement I just want to bring your attention to. There's a DUS statement. So that should get you all your parts, and then you can determine if it's angle, angle, side, or angle, side, angle. All right, for this one down here, again, I think it's easiest to separate these out, all right? So we're trying to prove, and sometimes it's useful to look at the proof statement to really see it. We're trying to prove ABC, so it's that triangle right there. So I'm going to redraw that. So A, here's B, here's C, and AED. So it's like this, AED. So I think it's easiest to separate out sometimes just because it gets a little overlapped and that gets hard to look at. And we do know that EA, this guy, is congruent to BA. Now you could mark that on here like this and like this. That's true. The one thing I want to caution you against is sometimes students will think that that means AC and AD. It does not. It only applies to the little segments it touches. So AE and AB, that's it. So that's why I like to separate them out. It just helps my brain. And then we know, I did not write that down. So EA is congruent to BA, it was given. And then angle D is congruent to angle C, also given. And then you might look at me and go, well, what else do we know? We don't really have any other line segments that overlap. You're right, we don't, but we do have an angle that's the same for both of them. And that's angle A. Right? Angle A is congruent to itself. So angle A is congruent to angle A. And that is reflexive property. So that means that we know angle triangle ABC is congruent to triangle AED. So many angles and triangles. How do I know that? Well, if I look up here, I can see that I have a side angle. Wait a second, there's no such thing as side angle. This must be angle, side congruence. So if you get side angle, just reverse it. And it works just fine. All right, there is another page of practice for you. This is super important, so I want to encourage you to do it. Email me if you have any questions. All right, email me if you have any questions.